Now let's consider a problem where we have increasing returns to scale. Okay, so now I'm just going to take revenue as P times Y. Okay, so I'm going to straight away find the supply function. So I'm going to consider, let's say, square root of Y. Okay, so this is increasing returns to scale problem. Okay, now again I'm going to draw marginal revenue and I'm going to draw marginal cost. So what is marginal revenue? P. What is marginal cost? 1 by 2 root Y. Yes. Okay, now let me sketch the graph of marginal revenue and marginal cost. So let's say P is positive. Okay, so if P is positive, marginal revenue will look like this. It's again a horizontal line. Okay, fine. And what about the marginal cost? Notice that as Y gets closer to 0, marginal cost is infinity. And as Y goes to infinity, marginal cost goes to 0. Okay, so what that means is it's a downward sloping curve. The marginal cost is a downward sloping curve, and it is asymptotic to the horizontal and the vertical axis, like this. Is that fine? Is that clear? Is that clear to everyone? Okay, so this is marginal revenue, which is P. Okay, and this is marginal cost. Okay, now now where do you think you should choose if you want to maximize your profit? Well, let's start from this point. Okay, so okay, so what do you think? What do you think about this point? Okay, so notice that you are only incurring losses if you choose this point. Yes, because marginal cost is above the marginal revenue. So the graph of the marginal cost is actually above the marginal revenue. So the difference between the total cost and the total revenue is positive. In other words, the difference between the total revenue and the total cost is negative. Okay, which means you are making losses. Can you see that, all of you? Okay, now if you choose this point, for example, this one, the point where there is an intersection, what happens? What happens if you choose this point? You are making a loss, maximum loss. This is not total revenue, total cost. Okay, please. This is where you ended up maximizing this area. This is the difference between the total revenue and the total cost. This is where you'll be maximizing losses. Is that clear? It's not break even. Okay, please pay attention. It's very important. Okay, just remember the graph. You are plotting marginal revenue, marginal cost, not total revenue, total cost. If total revenue is equal to total cost, then that's break even. That's not the point where you're breaking even. Is this fine? This is your revenue. Okay, let me just remind you again. Okay, and you have to keep this picture in mind. This is the revenue, this rectangle. And what is the cost? Cost is this entire thing, because it's the area below the marginal cost. So what is this difference? This is the loss. Yes or no? And this point is loss maximizing. Why is it loss maximizing? Because if you go to the right of it, you will end up reducing the loss. If you go to the left of it, you will end up reducing the loss. If you remember, when we plotted up till this quantity, the loss was less. Now when we are plotting, now let me show that if you choose this quantity, the loss will be lesser again. Okay, so notice that now you will be making profit on these quantities because price is above the marginal cost. So if I divide this particular quantity into quantity up to here, and then from this to this, then from here to here you will be making this much loss, and from here to here you will be making this much profit. So your net profit in this case will be this area minus this area. Is that clear? So if you want to raise your profit, you can actually go in this direction, and you can, you can keep making more and more money. Is that clear? Yes or no? Now notice that this area is going to keep on increasing. Okay, and in fact you can make infinite profits. So how do I show that? Well, what is this area? Can you tell me what is the area of this rectangle, this infinite dimensional rectangle? Well, not infinite dimensional, but the one with the infinite length. Okay, it is infinite, right? And do you agree this rectangle is a subset of this region? So you are making infinite profits. Yes, this is finite. So this is a finite value. This area is finite. This is infinite. So basically you can make infinite profits. So what that means is there is no finite solution to this problem. Is that okay? That is exactly what we saw in the total revenue, total cost approach. Remember? So what is the solution? No finite solution. Okay. So if I write Y as a set of solutions, then Y is an empty set. Okay. So you can say Y belongs to an empty set, which is saying that there is no solution. Is that clear? The optimal supply is, doesn't exist. Have you all understood this? And notice that this is true for all P positive. So you can say that Y as a function of P and put an S over here, okay, belongs to an empty set if P is positive. Okay, the reason is because this marginal cost is actually becoming asymptotic to the horizontal axis. So what that means is the distance between the marginal cost and the horizontal axis goes to 0. Okay, so what that means is as long as P is positive, no matter how small P is, you'll always be able to find a point beyond which you can make infinite profits. Is that okay? Is that okay? Okay, no matter how small P is. Okay, so that is why for any P positive, there is no solution to this problem. Okay, now what about if P is 0? Okay, let me draw again. Exactly, 0 supply. Okay, now you can see that you'll never be able to find an intersection. So if you will never be able to find an intersection, so that means you will only make losses if you try to produce a positive amount of output. Okay, and therefore you choose 0. Is that okay? So have you all understood this? Okay, good.